Hello friends, welcome to Dhruv Academy. Today we will be discussing this CSAT paper which UPSC has conducted as for preliminary exams on 25th May. There were 80 questions in the question paper, out of which 51 questions were pertaining to quantitative aptitude and logical reasoning that we will be discussing today. So let us start with the first question here. The first question, as you can see here, a natural number n is such that it can be expressed as n is equal to p plus q plus r, where p, q and r are distinct factors of n. How many numbers below 50 have this property? So here what we have to see is this. That means n, in particular any natural number n, it should be expressed as sum of three factors. Okay, so now p, q, r are distinct factors. Now let us try with some factors here. Say P, Q and R. Now they should be distinct. Okay, that means let us consider 1, 2, 3. So if you add this 1 plus 2 plus 3, it becomes 6. Okay, now 6, if you see this, 1, 2 and 3 are also factors of 6. Now we should know that there should be 3 factors. That means you cannot have prime numbers and the number should be at least 6 and above. See, because for 4 the factors are 1, 2 and 4. For which you cannot have this combination. So next, if you just go through this logic, the next factors for 12, the factors are 1, 2, 3, 4, 6 and 12. Again here if you add these 3 factors, say 2, 4 and 6. Okay, so 2 plus 4 plus 6, that is 12. So which satisfies this condition. Now if you go for the next 18, okay, 18, the factors are 1, 2, 3, 6, 9 and 18. Here also if you add these factors, say 3 plus 6 plus 9. So 9 plus 9, 18, which is again equal to n, the natural number. So by this logic, if you go like this, see all the multiples of 6. Okay, see the multiples of 1, 2, 3 factors. Okay, so 6, 12, 18. So like this, if you go up to 50, there will be 8 such factors. Okay, or 8 such numbers, natural numbers is 6. Okay, sorry. 6, 12, 18, 24, 30, 36, 42 and 48. So for this 8 numbers, their factors, okay, 3 factors, they will add to this given number. So here this option will be option C. So that is the first question here. Now let us move to the second question. The second question, 3 prime numbers P, Q, R each less than 20 are such that P minus Q is equal to Q minus R. How many distinct possible values can we get for P, Q, R? So here basically we have to first see, means restrict ourselves only to the prime numbers below 20. Prime numbers below 20, as we know, they are 2, 3, 5, 7, 11, 13, 17 and 19. So there are 8 prime numbers below 20. Now P minus Q is equal to Q minus R. P minus Q is equal to Q minus R. You can rewrite this as P plus R is equal to 2Q. Now 2Q, you are multiplying this Q by 2. So this number will be an even number. So P plus R, the sum is even number, which means the two numbers, both the two numbers should be odd. See, one even and one odd will not result in a even number. So that means we can just omit this 2. So now we will try with various combinations of P and R. Okay, so P plus R, or in fact it is 2Q and then Q. See, the first value for P will be 3. So if you add 3 plus 5, it will be 8. But then Q will be 4, which is not a prime number. 3 plus 7. So first combination is 3 plus 7. So P plus R is 10. And then Q will be 5. Again a prime number. So let us just add here P plus Q plus R also. So 10 plus 5, 50. Then the next combination for 3 and see 3, the next prime number is 11. So 3 plus 11 is 14. And then Q will be 7. So P plus Q plus R will be 21. The next combination 3 plus 13, 16. But then Q will be 8. 3 plus 17, 20. It will not work. 3 plus 19. So 3 plus 19 is 22. So Q will be 11. 11 into 2, 22. P plus R. So here this will be 33. P plus Q plus R will be 33. Now the next combination for 5. 5 plus 7 it is 12. So 6. 5 plus 11 16. 5 plus 13 18. 5 plus 17 again. 5 plus 17 is 22. So Q is 11. Then 33. Then 5 plus 19 gives us 24. But then Q will be 12. Okay, but we want only prime numbers. So next combination is 7 for 7. 7 and 11 18. 7 and 13. 7 17 and 7 19. Okay, so next one 11 13 11 18 and 11 and 32. Okay, so 28 20 24 and 30 26. So 26 and then it will be 30. So here it will be 39. Okay. Now next combinations, see 11 and 13 will give us a even number 24, but then 12, 11 plus 6 is 28, so Q will be 14, which we don't want. 11 plus 19 is 30, so Q should be 15. So which is not a prime. So 13 plus 17 again 30, 13 plus 19 is 32, so Q should be 16, that is not, and 13, 17 and 19, that is 36, so Q will be 18, which we don't know. So that means these are the 5 combinations. Okay, so 5 different combinations of PQR. But if you read the question carefully, how many distinct possible values can we get of P plus Q plus R? So here I have made this P plus Q plus R. So see here, if you see this, it is twice appearing. 33 is twice. Though the combinations are 5, the distinct values of P plus Q plus R are only 4. 15, 21, 33 and 39. Therefore, the answer will be A. If they just ask what are the different possible combinations of PQR, then it would have been 5 different combinations. But the values P plus Q plus R, distinct values will be only 4. So this is the answer. So option is A. Let us move to the next question. Third question here. How many possible values of P plus Q plus R are there satisfying 1 upon Q plus 1 upon Q plus 1 upon R is equal to 1, where P, Q, R are natural numbers, not necessarily distinct. Means they can be same. P plus Q, uh, P, Q, and R can be same. Just shift it here. So they can be distinct or they can be same. So let us assume say P is the smallest among them. So we have P less than equal to Q less than equal to R. So they may be same or they may be different numbers. Okay, that which means 1 upon P will be greater than 1 upon Q will be greater than 1 upon R. So now this one, see 1 upon P plus 1 upon P plus 1 upon P. It will be greater than equal to 1 upon P plus 1 upon Q plus 1 upon R, which is equal to 1. Which means 3 upon P is greater than equal to 1 or 3 is greater than equal to P. That means P can have 3 values 1, 2 and 3. So P can have 3 values and then Q and R can have assume the same values or they may be different. So let us start with the first value of P. Now we have this P 1 upon P this one. So 1 upon 1 plus 1 upon Q plus 1 upon R is equal to 1, which will give us 1 upon Q plus 1 upon R is equal to 0. But then see the addition of two numbers is giving us 0. That means one will be positive and one will be negative or both will be 0. But then they should be natural numbers, 3 natural numbers. Okay, so this combination is not working. So the next we will try with P is equal to 2. So if you take P as 2 in this equation, see this equation. So 1 upon 2 plus 1 upon Q plus 1 upon R is equal to 1, which means 1 upon Q plus 1 upon R is equal to 1 by 2. So here if you take the values of Q and R as 4, okay, so 1 upon 4 plus 1 upon 4, which gives us 2. That means one combination is 2, 4, 4. So we are getting one combination for say PQR as 2, 4, 4. Okay, then in the same combination, if you have Q and R as 3 and 6, okay, so 1 by 3 plus 1 by 6, it will also give you 1 half. So another combination is 2, 3, 6. And then third combination can be PQR all equal to 3. So then in that case, it will be 1 by 3 plus 1 by 3 plus 1 by 3, which is again 1. So the third combination is 3, 3, 3. That means we are having three combinations or three values of PQR, natural number, all natural numbers. Okay, so 244, 236, and 2 and 333. So there are three such possible values. Okay, how many possible values of P plus Q plus R? So if you see here, see 6 plus 4 plus 4 plus this, it is 10. 6 plus 3, 9 plus 2, 11, and this is 9. So these three different values. So the correct answer is option C, 3. We will go to the next question. What comes at X and Y respectively in the following sequence? So one sequence is given: January, January, December, October. X, you have to find out the value of X, March, October, Y, September. So you have to find out the values of X and Y. So here the logic is the position of the number of months. Okay. So like January is 1 and December is 12. So I'll just note here. See January, February, March, April, May, June, July, August, September, October, November, and December. Okay. So it is, see, January is 1, February 2, 3, 4, 5, 6, 7, 8, September is 9, October is 10, November 11, and December 12. Now, if you see this January, January, December, October, okay, the sequence given. The sequence given is January, I will just use the short form here. So January, December, October, then X, March, October, Y, and then September. So if you consider the positions of the number of the months, okay. So like January is 1, again 1, this is 12, October is 10, you have to find out X, March is 3, October 10, you have to find out Y, and September 9. Now what you observe here is, see 1 and 1. So here you are moving backwards, see from 1 to 12. When January you are moving backwards, see it will be cyclic. December, January, again December, and again comes January. So if you move backwards from January to December, it is one step back. See here, January to January means you are not moving, or you are moving 0 steps backwards. From January to December, you are moving 1 step backward. From December to October, you are moving 2 steps backwards. So 2 steps, if you see this 0, 1, 2, so if you continue the same pattern, so 10 minus 3, you are moving to 3 steps backwards. So from October, 3 steps backwards means there will be 7. So the month will be July. Okay. Now you have to move 4 steps backwards. See, already we have moved 4 steps. 7 minus 4, 3. Then 3 steps. From March, you have to move 5 steps backwards. See, from March, 1, 2, 3, 4, 5. So that is October, 5 steps backwards. Now we have to move 6 steps backwards. So from October, 6 steps backwards. So it should be 4th month. So that means it will be April. And then from April, 7 steps. See here 6 steps and 7 steps backwards. So from April, 7 steps backwards is 1, 2, 3, 4, 5, 6, 7. So it is September as given in the series. So what we get here is in place of X and Y is July and April. Okay, so that is this option. Option B. I hope it is correct. Okay, and you have understood it. Okay, so the month position of the months and their associated numbers. Okay, let us move to the next problem. The fifth problem. Team X scored a total of n runs in 20 overs. Team Y tied the score in 10% less overs. Had Team Y's average run rate, that means runs per over, been 50% higher, the scores would have been tied in 12 overs. How many runs were scored by Team X? So different options have been given: 72, 144, 216, and cannot be determined. Now we'll see how to do this. Glad that. So team X scored n runs. Okay. So X4, the P makes 4 N runs in 20 overs. Now Y has tied the match. That means Y has also scored N runs, but 10% less over. So Y scored N runs in 10% less overs. So it will be 10% less. See, 10% of 20 is 2. So 2 overs less means that is in 18 overs. Now, if you assume, say, suppose M is the average run rate of Y. So let M be the average run rate here. Okay. For Y. So average, that means Y is scoring M runs per over in 18 overs. So Y will score 18 M runs in 18 overs, which is again equal to N. Now had the average increase by 50% higher. So if you increase the average by 50%, it will be 150% or 3 by 2 times. So 50% increase in average will result in 3 by 2 average. So average will be 150%. So 150 by 100, that is 3 by 2 M. So now it will be 18, and now it will not be 18. See, instead of 18, now the Y will be tying the match in 12 overs. That means it will be scoring the runs in 12 overs. So it is M. That means here say 2 ones are 2 6 are. So it is 18M is equal to N. Now if you see in both the cases, we are getting the same equation. Okay, what it indicates is the total runs is 18M, that means some multiple of 18. So it could have been in any multiple of 18, like 18 to 36, 54, 72, and so on. Now if you observe the options here, okay, the options are, see, 72, 144, 216. So all are multiples of 18. So Y could have scored either 72, 144, or it may be 216 also. Or it can be some another runs, 180 runs also. So therefore the option will be cannot be determined. Because we are not sure whether it is 18M, whether it is 72, 144, 216, or some other number. So the option naturally will be the cannot be determined. So coming to the next question. The price P of a commodity is first increased by K%, then decreased by K%, again increased by K%, again decreased by K%. So alternatively it is increasing or decreasing by K%. If the new price is K, Q, then what is the relation between P and Q? So let us see how to go about this question. See, price, initial price P, okay? So initial prices P. Now, when the price increases by K%, that means it will be 100 plus K% of P. So, like 10% increase means it becomes 110, or it becomes 110% of the original. So, likewise, see 10% increase, or like instead of 10, we still K% here directly. So, K% increase. Okay, will lead the price to be P into 100 plus K percent, that is P into 100 plus K upon 100. Now there is further decrease of K%. So now the price will be 100 minus K% of the initial price or the previous price. So now K% decrease will lead the price to be P into 100 plus K upon 100 into 100 minus K upon 100. See, like 5% decrease means the price has become 100 minus 5. So 95% of the previous price. So 100 minus K here in this case. Now next is K% increase. So now the new price will be P into, see, 100 plus K% of the previous price. So 100 plus K of this. into 100 plus k%, because there is an increase of k%. And finally, there is a k% decrease in it. So it will be now P into 100 plus k upon 100 into 100 minus k upon 100 into 100 plus k upon 100 into 100 minus k upon 100. So 10% increase, 10% decrease, 10% increase, k% decrease. Okay, k%, not tens, I'm sorry. So now after this, see if you see this, observe here 100 plus k, okay, into 100 minus k. It is 100 square minus k square. Similarly, 100 plus k into 100 minus k. It is a plus b into a minus b. So 100 square minus k square. And here it will be 100 raised to 4. Okay. So p into 100 square minus k square whole square upon 100 raised to 4. So, and now this price is q. Now 100 square, 100 is basically 10 raised to 2. So 10 raised to 2 raised to 2 means it is 10 raised to 4. Okay, so p into 10 raised to 4 minus k square whole square upon, see 100 is 10 raised to 2. So 10 raised to 2 raised to 4, which will be 10 raised to 8 is equal to q. So then finally what you get is p will be, see p into 10 raised to 4 minus k square whole square is equal to q into 10 raised to 8. So this is the final thing. Okay, the relation between P and Q. So it is the option number 1. P into 10 raised to 4 minus K square whole square is Q into 10 raised to 8. Okay, so this is the thing. So option number 8. Correct option is 8. Okay, let's move to the next question. A solid cube is painted yellow on all its faces. The cube is then cut into 60 smaller but equal pieces. That means it is equal area and volume by making the minimum number of cuts. Which of the following statements is or are correct? First statement is the minimum number of cuts is 9. The number of smaller pieces which are not painted on any face is 6. Okay, now we'll see how to do this. See, for any cube having say dimensions, say suppose A into B into C, the cube in A into B into C. So if you want to cut it into equal pieces of unit length, okay, say like A centimeter, B centimeter and C centimeter are the dimensions, and you want to have smaller cubes of 1 centimeter by 1 centimeter by 1 centimeter, then you have to cut the cube, okay. So the number of cuts will be equal to A plus B plus C minus 3. Okay. Then you are painting the cube on all the sides, and when you cut it, there will be some cubes which will not have any face color. Okay, so that also you have to find out the number of smaller pieces which are not painted on any face. Okay, so number of cubes which are not painted on any face. This number will be given by A minus 2 into B minus 2 into C minus 2. So this is the basic thing. Okay, dimensions ABC. If you want to cut into smaller pieces of unit length, then A plus B plus C minus 3 will be the number of cuts. And number of cubes which are not painted on any face will be A minus 2, B minus 2, C minus 2. Now see 60 is the volume of the cube and you want to cut it into smaller pieces. Okay. Now you can have the number of pieces as say like 1 into 2 into 30. Okay, or you can have say 1 by 1 or that matter 1 by 1 by 60 also, the dimensions. Okay, so that means length 1, breadth 1 and width or height or depth, whatever you call is 60. Okay, but if you say, or you can have say like 1 into 4 into 50. But now here, see, the question is, whenever you cut it, the minimum number of cuts should be 9. See here, for example, here if you observe, say 1, 1 and 16, the number of cuts will be 1 plus 1 plus 16. Okay, we'll just see the number of cuts, 1 plus 1 plus 60 minus 3. So 62 minus 3, so there will be 59 cuts. But we want the number of cuts to be minimum. So if you go on this, the optimum size for this number of cuts to be minimum should be 3, 4, 5. Okay, so if you do this, okay, see, you'll have to see all this combination like this, but the minimum size will be like this. So the number of cuts will be 3 plus 4 plus 5 minus 3, which will be 9, the number of cuts, and the number of smaller pieces which are not painted on only face. So it will be given by this. So now the dimensions are 3, 4, and 5. So 3 minus 2, that is 1, into 2 into 3. So it will be 6. Okay, so we get our answer here. See, the minimum number of cuts is 9, and the number of smaller pieces which are not painted on any face is 6. That means here both the options 1 and both the statements 1 and 2 are correct. So it is option is C here. Okay. So this is the problem on the cubes. Okay, let's go to the next question. Some coding question here. See, 7 into 24 equal to 25, and 12 into 16 is equal to 20. Then what is 16 into 63 equal to? Okay, again this question based on coding, but backed by some mathematics or rather squares of the numbers. So one important point for the UPSC aspirants or for the CSAT part will be you should by heart or memorize all the squares at least up to 30 and the cubes up to 15 at least, because 1 or 2 questions you will be finding on cubes or squares usually. Okay, so here 7 into 24 is 25. Fine, then 12 into 16 is 20. And 16 into 63. We want to find out 16 into 63. See here, if you take the square of 7, okay, so 7 square plus 24 square, okay, it is 49 plus 576, which is 625, which is 25 square. Okay, so 7 square, 49 plus 24 square, 576, 725. So 12 square plus 16 square, that is 144 plus 256, that is 400, which is 20 square. Okay, so the logic is the number on the left hand side you have to square and the number on the right hand side. So sum of the squares and find out the square root. So it will, or the sum of the squares of these numbers will be this. So actually it is a Pythagorean trick, right? So here same way 16 square plus 63 square. So that is 256 plus. Okay, see 63 square. What will be the number here? Just anyone can tell me. So 3969. Okay. So if you add this, so it is 4225. Okay. Now 4225. Okay, you have to find out the square root of that number. So 4225 square root of 4225 will be 65. So the answer is 65. See how I'm getting, see for there is a trick for the numbers, finding out the squares of the numbers ending with 5. See 5 here. So if you want to find out say square root of 65, see it is 5 square is 25 and 6 into the next number, consequent number, 6 sevens are 42. See same way for example say 25, see here, 5 5s are 25, 2 3s are 6. So 625. So if you remember and memorize all these squares and cubes, it will be much faster. Okay. So the answer is 65, option C. We move to the next question. The petrol price shot up by 10% as a result of the hike in crude oil prices. The price of petrol before the hike was rupees 90 per liter. A person travels 2,200 km every month and his car gives a mileage of 16 km per liter. By how many kilometers should he reduce his travel if he wants to maintain his expenditure at the previous level. And the four options are 180 kilometers, 200 kilometers, 220 and 240. So let us go for this. So see, he is traveling 2200 kilometers every month and the mileage is 16 kilometers. So the petrol required for him is 2200 upon 16. Okay, that will be the petrol required. And then the price is equal to 2200 upon 16 into 90 rupees. So this is the original price. Okay, so I will just write here, this is the initial price. Okay, now revision. Revision, what happens is, see, revised price. Price has increased by 10%. Okay, see, there is increase of 10%. So 10% of 90 is 9. So the new price, is 99. The new price is 99 rupees. Now our question is about how many kilometers should he reduce his travel if he wants to maintain his expenditure at the previous level. That means his expenditure should be this. So now the new, suppose the new kilometer, no kilometer travel is say K. So now the petrol required will be K upon 16 because the mileage is 16 and the price will be 99. Now to keep the expenditure same, that means this should equate with 2200 upon 16 into 9. Okay, so K, you have to find out now K. K will be 2200 into 99. Okay, so here see 9 into 11, 9 tens are. This is 11 twos are 200 into 10. So K is 2000 kilometers. Earlier he was traveling 2200 kilometers. Now he is traveling 2000 kilometers. That means 200 kilometers less. So you should reduce his travel by 200 kilometers to keep the expenditure same. So to keep the expenditure same, he has reduced that much. So option is B. Okay, so 2200 is the kilometer, mileage is 16. So this is the petrol required. This is the price. And we get K as 2000. So reduction of 200 kilometers. Next question. A 4-digit number is n is such that when divided by 3, 5, 6 or 9 leaves a remainder of 1, 3, 4, 7 respectively. What is the smallest value of n? So 4 values have been given. See here, this is the problem. You have to find out the LCM here. If you observe here, see the divisors and the remainders. Okay, the respective divisors. See the difference between the dividers and remainder is 2 here. See 3 minus 1, when divided by 3, the remainder is 1. When divided by 5, the remainder is 3 and so on. So always the difference is 2. So here what we'll do is, first we'll find out the LCM of 3, 5, 6, 9. And then we will find out a multiple of that LCM which is in this range. So now coming to this finding out LCM of 3, 5, 6, 9. Okay. So this LCM here will be 90. Okay. So LCM you can find out by any of the methods. So it comes to 90 here. LCM is 90. Now the multiple of 90 which is closer to this. Okay. So if you just go see 90 into 12, that is 1080. And then we have to subtract that 2, the difference from this number. So that is 10078. Okay. See why we have to subtract 2? Because the difference between the divisors and remainder is always 2. See, just take this simple case 90. Okay, if you subtract 2 from this, say 90 minus 2, that is 88. Now if you divide this by 3, okay, see 29 3s are 87, so remainder is 1. Then if you divide it by 5, 17 5s are 85, the remainder is 3 as given. If you divide it by 6, okay, so 14 6 are 84, the remainder is 4. And if you divide it by 9, 9 9s are 81, so remainder is 7. So every time if you subtract this 2 from the multiple or the common multiple, then you will get the desired answer. So here the answer is 1078. Okay, so LCM. Next, consider the following statements: A less than B, greater than C, less than D, less than, greater than E, greater than F, greater than equal to G, equal to H. Then B is always greater than E. Similarly, P greater than Q, equal to R, which is greater than equal to S, equal to T, less than equal to U, equal to V, greater than W. Then S is always less than B. Which of the statement or statements given above is correct or correct? See, if you observe here, see B is greater than C, but it is less than D. So the symbol, see, the shortcut here trick is if all the numbers, say for example, see take some different cases, say L greater than M, greater than equal to N, greater than equal to S, and so on. So in this case, all the symbols they are unidirectional. So L is greater than M, it is greater than equal to N and then S. Then here you can compare L and N or M and S or L and S, etc. But if you observe here, say this and this and this, okay, they are pointing in all different directions. So here the finding out the exact relation between B and A will not be possible here. Same way here. See, you have to find out the relation between S and V. See, S and V here. So here S equal to T is less than equal to U is equal to V. But because of this equal to or less than or equal to sign, S can be either smaller than V or it can be equal to V also. So again, the relation is not possible here to find out. Okay. So here, which of the statement given above is or correct? Because the word used is always. See, sometimes it may be the case, but not always. So that's why our option is neither one nor two. So neither of the statement given is true. Okay. So this is the problem on inequality. Next one. What is the unit digit in the multiplication of 1 into 3 into 5 into 7 into 9 up to 999? And the options are 1, 3, 5 and 9. Here you have to find out means, see, basically if you observe the numbers, all the numbers are odd numbers. So you have to find out all product of all the odd numbers from 1 to 999. So if you observe this, see there will be 1 5. So any number now multiplied with 5 will always end with 5. See the table of 5. 5 ones are 5, 5 twos are 10, 5 threes are 15. But all the odd multiples, see here we are not having any even multiples because there is no even number. So all the odd numbers, all the multiples of 5 will result in the number ending with 5. The unit place digit of that number will be 5. So same way in this product, say 1 into 3 into 7 into all those numbers. So there will be 5, there will be 15, there will be 25. Okay, so the product last number will be always 3, ending with 3. Oh, sorry, I mean 5. Okay, so it will be 5. Okay, because we are multiplying the numbers with 5. So just a very simple thing. Okay, unit place digit. See, again, every time UPSC is asking some question of this. What is the last digit or unit digit in the product so and so or addition and so on and so. So please prepare this. Go to the next one. Consider the first 100 natural numbers. How many of them are not divisible by any one of 2, 3, 5, 7 and 9? That means from 1 to 100, see there are 100 natural numbers, 1 to 100. From this, we have to rule out those numbers or take out those numbers which are divisible by 2, 3, 5, 7 and 9. Now number divisible by 2 means all the even numbers. So all the even numbers from 1 to 100 are ruled out. So we have to just consider all the odd numbers. Then number divisible by 5. That means all the numbers ending with 5. Okay, 5, 15, 25, etc. are also ruled out. So after taking out all the numbers which are divisible by 2 and 5, what remains is like this. See, first one will be 1, 11, 21, 31. Just I will take some time writing this, please bear with me. So 41, 51, 61, 71, 81, 91. Then 2, 4, etc. We don't want that number because we have ruled out all the even numbers. Then 3, 30, 23, 33, 43, 53, 63, 73, 83, 93. Okay. Again, even numbers we are ruled out. So 5 also we are ruled out because it is divided by 5. So next is 7, 17, 27, 37, 47, 57, 67, 77, 87 and 97. And lastly, 9, 19, 29, 39, 49, 59, 69, 79, 89 and 99. Now we'll be taking out the numbers or which are multiples of 3. So if you take out all the multiples of 3, naturally we will take out all the multiples of 9 also. So I will just cancel out those multiples. 33, 39, then 51, 57, 63, 69, and 81, 87, 93, 99. Okay, so up to this stage, we have ruled out all the numbers divisible by 2, numbers divisible by 5, numbers divisible by 3 and 9. Now, what remains is to be numbers to be striked out which are divisible by 7. So, now coming to this, it is 7. Okay, then 31, 49. Next is 90, 77 and 91. Okay, so now what are the numbers remaining? They are not divisible by any of these numbers. So we'll just have to count out those numbers now. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there are 22 such numbers. Okay, so you have to go methodically step by step by eliminating numbers. So you don't have to waste your time writing all the 100. So what we have done here is first we have ruled out all the even numbers because divisible by 2 means even numbers, and then 5. So like 5, 15, etc. So I have not written those numbers. So I have just written this 4. All the odd numbers, again excluding ending with 5. And then we have found out just 22 numbers. So correct option is C. If 4 is less than equal to x is less than 8 and 2 is less than equal to y less than equal to 7, then what is the ratio of maximum value of x plus y to minimum value of x minus y? Now here see minimum and maximum values of x and y. See, I will just write here minimum value, maximum value of x and y. So x can have maximum value as 8, minimum value as 4. For y, the minimum value is 2, the maximum value is 7. Okay. Now maximum value of x plus y. See the maximum value. Will be 8 plus 7. That is 15. Okay. The minimum value. Now minimum value of x minus y. Okay. Minimum value for having minimum value of x minus y. What you should have is see 4 minus 7. That will be the minimum value. Minimum value of x minus y. It will be 4 minus 7. That is minus 3. So ratio of maximum value of x plus y to minimum value of x minus y. It will be 15 upon minus 3. Minimum value of x minus y, maximum value. Okay. So here that option is not there. See the options are 6, 15 by 2, minus 15 by 2. So none of the above. So the correct option is none of that. See, while taking maximum value, we are adding maximum values here. But for finding out minimum value, we are taking those minimum value of x and maximum value of y. Because there is no other condition that the difference should be positive or negative, etc. So it can be this minus 3 also. So none of the above is the option. Okay. Now let us move on to the next one. Let both p and k be prime numbers such that p square plus k is also a prime number less than 30. What is the number of possible values of k? So p and k are the numbers, okay, prime numbers, and p square plus k should also be prime number less than 30. So prime numbers, see, we'll just see prime numbers less than 30. Okay, so 2, 3, 5, 7, 11, etc. Okay, but out of this, what can be the values of p? Okay, p square. Now you just see p square. So p square, if you take p as 7, 7 square, 49 itself is greater than 30. Okay, so we cannot have that value of p. So we can maximum value of p we can restrict is up to 5 only. So now see, we will just try with different values of p, k, and p square plus k. Again, the p square plus k should be 30. So see p square plus k. Okay. So the first value p, we can take it as 2. So 2 square is 4. Okay, 1 second. I'll just add k also here and p square plus k. Now we want p square plus k as a prime number less than 30. So what are the different options? See, if you add 4, okay, and we want to add the prime numbers only. So first prime is 3. So 4 plus 3, which is 7. So it is also a prime number. So that is the first combination. See, both p and k prime numbers, 2 and 3. P square plus k is also a prime number less than 30. So next combination, 2, 4. We will just check whether any other combination for this number 2 is there. Say 2, if you take k as 5, okay, so 4 plus 5, 9. K as 7, okay, so 4 plus 7, 11. Again, a prime number less than 30. Then next combination, 2 plus 4, 11, 13. The next combination is 13. So 13 plus 7 is 70. Prime number less than 30. Okay, then the next 2, 4. The next prime number is say 17, then 23 and 29. If you take 29 here, 33 and that number will be more than this. So that is the only combination here now for values of 2. Then next value of p can be 3. So 3 square is 9. Okay, so 9 plus 2, that is 11. Now for this 9, okay, you can have only one value, even value here, because if you take any odd value here, see, we know that only one even prime number is even and rest of the prime numbers are odd. So this 3 being an odd number, its square will be odd, and if you add odd number here, you will get the result p square plus k as even number. Okay, but that cannot be a prime number. So we will have to consider only one number here. Okay, the next prime number is p is 5. So it is 25. Now 25 plus if you add 2 or 3 or 5, okay, you cannot have a prime number there. So there will be only 4 possible combinations. So 2, 4, 3, then 2, 4, 7, 2, 4, 13, 3, 9, 12. So there will be 3 such combinations here. So correct option is 4. Okay. So prime numbers, see, right now if you are seeing there were not many questions on prime numbers and number systems. Okay, so please practice thoroughly for the number systems, prime numbers, divisibility, LCM, SCM, and so on. The next, there are n sets of numbers, each having only 3 positive integers, with LCM equal to 1001 and SCF equal to 1. What is the value of n? The options are 6, 7, 8, and more than 8. So here we'll just have some space here. LCM and SCF. Again, second or third question based on LCM and SCF. Now the SCF is equal to 1. Okay, which tells us that all the numbers are co-prime. There is no common factor. Because see, for the co-prime numbers, SCF is 1 and the LCM will be product of the numbers. So SCF is 1, LCM is 1001. So we will try to find out the factors of 1001. Now 1001 is not divisible by 2, it is not divisible by 3, not divisible by 5. So let us check for 7. So 7, 3, 7, 4 are 28 and 7 3s are 21. So it is 7 into 143. Again, if you divide this, so it will be 7 into 11 into 30. Okay, so this is the prime factorization of this one. So now if you take these 3 numbers, say 7, 11 and 13, they are co-prime numbers. So their LCM will be 1001, HCl will be 1. So this is the one combination. Okay. So 7, 11 and 13. Now you can have the products of these two numbers and different combinations. So like another combination can be 7, 11 and 11 into 13. So 143. Or it can be 7, 11 and any other combinations not possible. Or see 7 and 13 into 7, 91 and 143. Okay. So another combination can be 11, then 77 and 143. Okay. Or 11 and 77 and 91. So many combinations there. So if you just go on listing it like that, it will be more than 8. Just we'll try to find out at least 8 or 9, so we can be sure. Okay. So any other combination here? See 7 into 91 into this, 11 into 7. What else? See now 13, 13 and 11 and 77, 13 and 143 and 77. So 7 at least. No, anything else? So it is like just tricky, you have to just do trial and error. So just go on finding out the combinations here. Yeah, here 11, 77, 143, 13 and 7, 91. See 91, 11 and 143. Okay, so at least 8. Then any other? 91, 11 and 77. Okay, so see right now at least up to we have found out see 4 plus 3, 7 plus 2, 9. Okay, so at least 9 are there. See, our purpose is solved. There may be more or there may not be more. But what we are seeing here is, see this option is more than 8. If it would have been more than 9 or more than 10, we would have done additional options. Okay, so these are the options. This is how you have to go on. So please practice this LCM and SCF also. Okay, many times the questions are coming on that. Let PQR be a 3-digit number. PPT is a 3-digit number and PS be a 2-digit number, where PQ, RST are distinct non-zero digits. Further, PQR minus PS is equal to PPT. If Q is equal to 3 and T is less than 6, then what is the number of possible values of R and S? Okay, so this is a simple question again based on the normal subtraction method. So the carry and all those things. So we'll just see how to go about this. See here it is given as PQR minus PS is equal to PPT. PQR minus PS is equal to PPT. So I can rewrite this as PQR minus PPT is equal to PS. Okay, and I will just write it in this fashion. Say PQR minus PPT and PS. Okay, now there are two additional conditions given, Q equal to 3 and T less than 6. And all the this 5 numbers are distinct numbers. Okay. So here, see, first I will just write 3 number here. Okay. Now if you observe here, see 3 minus some number is giving again this same number here. So which cannot happen unless there is a carry here. Okay, so Q minus 1 and then T. It can be like that. Okay, then T less than 6. So T can have values of 5, etc. Okay. So the one combination can be like this, see 3, 1. So you'll have to just use some, okay. Then R and T. So first we will try with say T can be less than 6, but T cannot be 1, 3 or etc. So if T can be here, say 4 or 5 directly here, say 5. Okay. Then PS, then that number should be also again a separate number, not any among this. So what values you can here see? One, for example, one such number is like this. 134 minus 115, which satisfies all these conditions. Okay. So all these numbers, see P, here if you subtract this, 9. So carry 1 here. So this is 2 minus 1 is 1 and 1 minus 1 0. So see P, and this all this 4 different numbers. So this is one combination. You have to find out such combinations more. Okay. Now here, see this, that means 1, 3 and 3. You have to keep those numbers same here. Okay, any other combination here now? See 1, 3. Can you have here 5 or 6 or 2 here? Okay, so you can have 2 here or yeah. So 1, 3, 2. So you'll have to just check here 1, 1 and then 3 here or 4. See this can be also another number. So 18 here. Then another combination it can be like this 1, 3, 2, 1, 1, 5, 17. Okay. So this is like this. So where now can you have 2 and 2 here? Okay. See P cannot be 2 here because the reason is the 3 minus 2. Okay. It will be giving us 1. So it should be 3 and 1 only where and carry 1. Okay. Or can you have something like this? See, just see, because this 3 is there, Q is 3, so you'll have the limited options only. So 3 options only. Okay, and then what is the number of possible values of R and S? Okay, so what are the possible values of R and S? See this one, RS, RS, and RS. So there are 3 possible values for R and S. Okay, so this is the option. Okay, consider the sequence. Now this is something called as rhythmic arrangement. Okay, consider the sequence AB dash CC dash A dash B CCC dash BBC dash C that follows a certain pattern. Which one of the following completes the sequence? Okay, just I think I will just do it here itself. See, here the one way to solve it is here to break this into different parts, okay, depending on the number of characters. Now, if you count this, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 characters. So there can be groups of say 3, 6 groups of 3 or maybe 3 groups of 6 each. So we'll try both ways. So see here, if you observe here, see every time see this B, B and etc. So the pattern can be A, B, B, C, 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 A, B, B, C, 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 A, B, B, C, C, C. So I will just write those numbers, letters here. So B, C, B, A, B, B and C, C, C. So B, C, B, A, C. See the missing letters are B, C, B, A, C. Okay. So B, C, B, A, C. That is the option. So you divide that given string into smaller parts. See, sometimes it may be for 5 groups of 4 or 4 groups of 4 each, etc. So here BC, that is the option. Option C. So it is this type of arrangement is also referred as the rhythmic arrangement. Let's put something. No. In 9. Yeah. What is the maximum value of n such that n that 7 into 343 into 385 into 1000 into 2401 into 7777 is divisible by 35 raised to n. Now see this divisor 35 raised to n. Okay. Here the factors of 35 are 5 and 7 only. So now we will try to find out the number of times 5 or 7 appears in this to get the answer of this. Now if you observe this number, see 7. Okay, 7, that means 7 is to 1. Then this 343. It is 7 cube. Okay, 385. So just I will just find out the factors here. See 385 is 5 into 5 into 7 into 11. See 1000 is 125 into 8 or 5 cube into 2 cube. Then 2401. Okay, it is not divisible 6, not divisible by 3, so you have to divide it by 7. 7 3s are 7 4s are, yeah. 7 into 7 3s are 21. 2 7 21 3 7 4s are 30 and 7 3s are. So 7 into 7 cube or 7 raised to 4. And then 77 is 7 into 11. So if you just see here, see 7 raised to 1, 3, 1 and 4. So it's 1 plus 3, 4 plus 1, 5 plus 1, 6. 7, 5 plus 4, 9 plus 1, 10. So 7 raised to 10 is there. And for 5 it is 5 raised to 1 and 5 raised to 3. So 5 raised to 4. Okay. So to get 35, we can have 7 raised to 4 into 5 raised to 4 or 35 raised to 4. So that is the maximum value of n. So maximum value of n is 4 here. Okay. Because see, we are factorizing it. 35 into factors of 5 and 7, and we are trying to find out how many times, maximum number of times 5 appears and 7 appears, and pair it. See here, though 7 is appearing maximum times, 10 times, but there is no matching 5. So we have to restrict ourselves only to 5 raised to 4 and 7 raised to 4. So value of n is equal to 4. So option B here. See, this type of questions are also repeating many times. Okay, questions on remainders or the last digit in the product and etc. What is the value of x in the sequence 24, x, 12, 18, 36, 90 and so on. So I will just write down the numbers here. So I have to find out x here. So here since the x is in the beginning itself, we will start finding out the pattern from last. Okay, see if you observe here, all the numbers are this multiples of each other, etc. So if you divide say 90 by 36, okay, 90 by 36 is 2.5. 36 divided by 18 is 2. 18 divided by 12, it is 1.5. Okay. So if you want to continue this pattern, see every time this factor is reducing by 0.5, 2.5 to 1.5. So the next factor will be 1. So 12 divided by 1 is again 12 and then 0.5. See 12 divided by 0.5 is equal to 24. So that completes the pattern. So the required number is 12. So sequence. Usually it will be some multiples and this one. So 12 option B. So for this, fast calculation will be needed. So for that, what I suggest is you please memorize all the tables 1 to 30. So such type of questions can be easily handled. Okay, next one. P and Q walk along a circular track. They start at 5 a.m. from the same point in opposite directions. P walks it should be A at an average speed of 5 rounds per hour, and Q walks at an average speed of 3 rounds per hour. How many times will they cross each other between 5 a.m. and 7 a.m.? Now see, there is some circular track here. Suppose they start from this. So P is walking in this direction, Q is walking in this direction. So that they are walking in opposite direction. So their relative speed is the addition of their speeds. See, P speed is P is 5. 5 rounds per hour, and then Q is 3 rounds per hour. Okay. So relative speed, that is P plus Q, is 8 rounds per hour. Okay, so in this 8 rounds per hour, since they are walking in the opposite directions, they will be meeting 8 times in 1 hour. Or so they will be meet 8 times in 1 hour, which is 60 minutes. Okay, so they will meet 60 by 8. 8 7, so 7.5 minutes. So every 7.5 minutes they will be meeting. Now we have to calculate it from this 5:20 to 7. Okay, see they have started from 5. So from 5 to 7 a.m. that is 2 hours, or that means 120 minutes. So that will be, see, at the rate of 8 rounds per hour or 8 meetings per hour, there will be 16 such meetings. They will meet 16 times. Okay, now, but we have to see here the problem takes from 5:20 to 7 a.m. See, between 5 to 5:20 a.m., see 5 to 5:20, they will meet at 5 hours, 7.5 minutes, because they will be meeting every 7.5 minutes, and then 5 hours and 15 minutes. See, the next will be 5 hours, 22.5 minutes, so which will be in our range. So you have to exclude these 2 meetings from that 16 meetings. So 16 minus 2. So they will meet 14 times during this 5:20 to 7. So here the relative speed concept, because both are moving in opposite directions. So 5 rounds plus 3 rounds, they will be making 8 rounds per hour, or in other words, they will be meeting 8 times since they are moving in opposite directions. So we have taken this in 20 minutes, this 2 rounds we have taken out. So reduce that from that total 60. So there will be 14 rounds or 14 meetings. They will cross each other between 5:20 to 7. So option C. Just excuse me. So next question is question number 38. P is equal to, see here again the letters have been coded. See, 4 mathematical operations plus, minus, multiplication and division, they are coded as P, Q, R, S. So P is equal to plus, Q is equal to minus, R is equal to sorry, R is equal to multiplication, S is equal to division. Then insert the proper notations between the successive numbers in the equation. 60 minus 15 minus, that means this time we'll write it here, 60, 50, 3, 20, 4, equal to 20. Okay. So naturally, if you observe these numbers, 60 and 15, if you suppose say multiply 60 by 15, so it will be 900, and then the remaining, even if you add or divide, it may not be 20. So first, see, the first option is S. Okay, so we'll just see one by one options. So S, so divide, P is plus, then R means multiplication, and Q, that is minus. So now here strictly you have to follow this BODMAS rule. Okay, so always remember for any mathematical operators involving more than one mathematical operators, you have to use this BODMAS rule. So as per this BODMAS rule, 60 divided by 15 is 4, plus 3 into 20, 60, minus 4. Now which is not 20. We want the answer as 20. Okay, so we'll see the next option, QRPS. So 60, Q means minus 50. R is into 5 into 3. Then P means plus 20 and S is division. See, we are now trying the second option, QRPS. CQRPS. Okay. Now again you have to use this bond mass rule. So 15 into 3, 45. So 60 minus 45 plus 20 divided by 4 is 5. So 15 plus 5, which is 20. That is equal to the right answer. So which gives us this correct option as QRPS. So the second option for question number 38, it will be option number B. Okay, so see, basically all the questions are based on the concept, different concepts. Like here we have to use bond mass concept, basic mathematical operators, and so on. So please make your concepts very clear. Okay. See, UPSC does not want you to have more calculations. It is not more calculation oriented, but more logic oriented questions. Okay, you have to just use the basic concept of the properties and you can get the answers. Of course, some questions like this, there you need some calculations, of course. But again, what I will advise is, see, there are 51 questions. Okay, so you have to prioritize your questions. Which questions you will be solving first, and then which questions you will be solving afterwards. So those questions which require more time for calculations, you keep them for the last. Those questions, like see the earlier questions, which you can do easily in say 1 minute, maybe 1 minute, those questions you attempt first. Okay, so like low hanging fruits, you collect those fruits first and then go for the questions which require more time. So like in this case, see, a tram overtakes two persons X and Y walking at an average speed of 3 km per hour and 4 km per hour in the same direction and completely passes them in 8 seconds and 9 seconds respectively. What is the length of the tram? So this question is based on the concepts of the trains, etc. Trains crossing in the same direction, opposite direction, etc. Okay. So here, see, we have to find out the length of the tram. Okay. Again, speed of the tram is also not given. So we'll have to assume the speed of the tram also. So let length of tram dt and speed b is kilometer per hour. So speed is in meters and speed b as kilometer per hour. Okay. Now we know that whenever a train or tram is crossing a person, the distance covered. See, basically the formula for the speed time distance is distance equal to speed into time. The distance covered will be given by speed into time. Now we know that here the speed, since both the objects are moving, there will be concept of relative speed. Now this tram and the person, they are moving in the same direction. So the relative speed at which the tram passes will be the difference in the speed. Speed of the tram, speed of the train minus speed of the person. It will be the relative speed. Same direction, so difference in the speed. Okay. Now time will be absolute, whatever the seconds, etc. The distance covered. The distance covered in this case will be the length of the tram. Okay. So if you take this formula, d is equal to speed into time. Okay. When the tram crosses first person. Okay. Now length of the tram. Okay. Length of the tram is t. So that is the distance covered when a tram is crossing a person. Then speed of the tram. Speed of the tram is s minus speed of the person. First person is walking at 3 km per hour. See, 3 km per hour. Now this speed is in kilometer per hour and the length of the tram etc. is in meters. So we'll have to convert this speed into from kilometer per hour to meter per hour. So for that we'll have to multiply it by pi by 18. So this is the speed into time. The time is in 8 seconds into 8. So this is the first equation we get. The second equation, tram crossing the other person. Crossing second person. Okay, again the distance covered is same because the tram is same, length of the tram is same. So t is equal to, here in this case the speed of the person is 4 km per hour. See here this 4 km per hour. Okay, so s minus 4 into again converted into meter per second 5 by 18 and that time is 9 seconds. So since both this length of the same tram, we can just equate the right hand side. Okay, so right hand side is minus 3 into 5 by 18 into 8 is equal to s minus 4 into 5 by 18 into 9. See, just this 5 by 18, 5 by 18, you can just cancel out. So here 8s minus 24 is equal to 9s minus 36. So s is equal to 12. Okay, so we get the speed of the tram as 12 kilometer per hour. Now you substitute this value in either this equation or this equation, second or first equation, and you can get the value of this tree length of the tram. Okay, so if you substitute this value here in this equation, so t equal to 12 minus 4 into 5 by 18 into 9. Okay, so 9 to 18, this is 8, 2 4s are 8, and 4 5s are 20. So length of the tram is 20 meters. Okay, so what we have done here is, see this, just I will read. So basic formula is distance equal to speed into time. When the tram or is crossing a person, okay, length of the person is taken as 0. So the distance covered will be length of the tram. The tram and the person are moving in the same direction. So the relative speed at which they cross each other will be the difference in the speed. Okay, so s minus 3. To convert it into meter per second multiplied by 5 by 18 into the time. So this is the first equation. Second equation, we are equating it. Then first we will get the value of s, speed of the tram here. See the speed of the tram. And then using that speed of the tram, we have got this 20. Okay, that is the length of the tram. So this is the option, 20 meter. No, we'll go to, so again, based on the trains and boats, etc., speed time distance problem. If n square is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 87, and so on, then how many digits does the number n have? Okay, I think similar question was earlier in some earlier year also. See, if you observe this 1, 2, 3, 4, 5 this, okay, basically if you see this 11 square is 121. Okay, if you find out, say, next, okay, so 11 square is this. If you find out 11 square, okay, it will be 1, 2, 3, 2, 1. If you find out 1, 1, 1 square, it will be 1, 2, 3, 4, 3, 2, 1. Okay. See here, it is 1, 2, 1. See, means 1 increasing up to 2, again decreasing. 1, 2, 3, decreasing to 1. 1, 2, 3, 4, and then increasing and decreasing. But if you see the middle number here and see this. Okay, so sorry, it should be not this. Rather, I want to say this one. The number of the digits. So when there were 2 digits, the maximum number 2. When there are 3 digits, the number is 3. When there are 4 digits, the number is 4. So see, using the same logic here, see this number here, 9. Okay. So that means it will be 11 square. So n raised to 2. Okay. So how many digits does n will be having? So n will be having 9 digits. Because there is the 9 number in the middle. So 1, 2, 3, 4, 5, 6, 9, then 8, 7, 6, 5, 4, 3, 2, 1. Yes, again, there are some questions based on the squares, cubes, etc. So the correct option will be B is equal to 9. Option B. Okay, next question is, say X of 20 pipes can fill 70% of a tank in 14 minutes. Another set Y of 10 pipes fills 3/8 of the tank in 6 minutes. A third set Z of 16 pipes can empty half of the tank in 20 minutes. If half of the pipes of X are closed and only half of the pipes of Y are open, all pipes of the set Z are open, then how long will it take to fill 50% of the tank? Now this is based on the which concept? That is the time and work concept. Sorry. Time and work. So there are 3 set of pipes. Say X, 20 pipes in 70%. That means 70 by 100 tank in 14 minutes. See, for X it is the number of pipes, portion, part of the tank, and in minutes. See, basically, we will try to find out one pipe will fill how much time, part of the time in 1 minute. And then from 1 to many, see like unitary method. And this one. So for X set of pipes, 20 pipes fill 70%. That means 70 by 100 of the time in 14 minutes. Okay. So one pipe in 1 minute. To find out one pipe in 1 minute, it will be how much? 70 upon 20 into 100 into 40. So it is 1 by 400. That means for set X, one pipe in 1 minute can fill up 1 by 400 of the tank. Same way for Y, to find out for Y, it is 10 pipes filling up 3/8 of the tank in 6 minutes. Okay, so one pipe in 1 minute will fill up. So that is 1 by 160. 1 by 160 part of the tank in 1 minute. Now see, this Z is empty. That means it is doing some negative work. So we have to keep it in mind to assign a minus sign there. So for Z, it is one. How many pipes are 16 pipes? Can empty one half of the tank in 20 minutes. Okay. So one pipe in 1 minute will be doing 1 by 16 into 2 into 20. Half of the pipes. 16. So 32 into this, that is 1 by 640. Okay, so X is doing 1 by 140. 1 by 400, 1 by 60, 1 by 640. Now see here, now what they are saying is, if half of the pipes of set X are closed, that means half are open. So 10 pipes are open. So now what we'll do is, yeah. See, for X, 10 pipes are open. One pipe is filling up 1 by 400 in 1 minute. So in 1 minute, okay, 10 pipes of X. So it will be 10 upon 400 plus Y. See, only half of the pipes of Y are open. Now there are 10 pipes of Y. That means only 5 pipes are open. So 5 upon 160. Okay, because one pipe of Y is filling up 1 by 60th of the tank. And then Z. Okay, Z. All the pipes of the Z are open, but it is now negative work. So Z, there are 16 pipes upon 640. Okay. So see, this is 1 by 40. This is 1 by 40. And this is 1 by 32. See, 1 by 40 minus 1 by 20. So 1 by 32. Okay. So in 1 minute, this 10 pipes of X, 5 pipes of Y, and 16 pipes of Z are open. Then 132 of tank will be filled. Okay, that means they need, in other words, they need 32 minutes to fill entire tank. Okay, so naturally for entire tank they need 32 minutes. So see, we need only to take 50% of the time. See here, 50% of the time means half of the time. So 16 minutes to fill 50% of entire tank. Okay, so the options is 16 minutes. Okay, so this is the question is based on the concept of time and work. Though it is, see, some books it is taken into pipes and systems, but the basic concept is time and work. Okay, so like this 45 questions. So friends, what we will do is we will take a break. Okay, and in the next section, we will be doing the next question. So for right now, we will take a break. Okay. So please, as I said, already the concepts. Okay. If you go through the last 4 5 years papers, more of the questions are based on the number systems like prime numbers, natural numbers, real numbers. So please make your concepts very clear. Okay. Conceptual understanding should be more, because if you have observed, see up to this, there are hardly 2 3 questions which require more calculations. Okay, but basically logical reasoning is more required. Okay, so we'll stop here. Thank you. Have a good day. Okay, and all the best.